Hi everyone, Assalamualaikum. In this video, we are going to continue with evaluating limits using multiplication by the conjugate. We use this technique when limit x approaches a fx over gx equals to 0 over 0 and the question is given in terms of radical function. To solve certain limits problem, you will need the conjugate multiplication technique when substitution doesn't work in the original function, right? Before we go further, let's look at this. What is a conjugate in math? The conjugate is where we change the sign in the middle of two terms. We only use it in expression with two terms called binomial, right? Radical expressions that involve a sum of difference of the two terms are called conjugates. We look at examples of radical conjugate. We have three columns here: binomial, sign change, and conjugate. Let's say we have binomial third x plus 2, or we can call radical x plus 2. Okay, radical means the symbol of square root or third here. Okay, if we have binomial third x plus 2, when we sign the change from positive to negative, we will get their conjugate, which is third x minus 2. Okay, we change plus sign to minus sign. So this is called conjugate of this binomial. Right? Look at the second one. If we have 3 minus third x, okay? Let's say we change from minus sign to positive sign. So we get this, okay? We have 3 plus third x. This is called conjugate of this binomial, right? From here, we change minus sign to positive sign. Right? And then, look at the other one. Let's say if we have third 1 minus x, or radical 1 minus x, and then plus 2. Okay? If we change the plus sign outside radical sign here, so from here, let's say we change plus to minus. Okay? Then we get this. Radical of 1 minus x minus 2. We just change the plus sign outside radical sign here. Okay, we change to minus sign. So this is called the conjugate of this binomial. Okay, we no need to change minus sign inside radical symbol because this is considered one term. Okay, we only change the sign outside radical symbol. Okay, we change plus sign here to minus sign. Okay, then we get the conjugate of this binomial. Okay, binomial means two terms. This is the first term and this is the second term. Okay, this is not two terms because this expression is inside radical sign. Okay, means it's come together. So we consider one term. Alright? So we still use the same sign. Okay, we still use minus sign for the sign in radical symbol. Right? And then look at other example. Let's say if we have binomial 3 minus radical x minus 1. Okay, from here we change from minus sign to positive sign. So we get this. Okay, we get 3 plus radical x minus 1. Okay, this is called the conjugate of this binomial. Okay, we just change minus sign outside radical symbol. Okay, we change from minus sign to positive sign. Okay, but we doesn't change minus sign inside radical symbol because this is considered one term. right? Binomial means two terms. This is the first term and this is the second term. Okay, we just change the symbol between the two terms. Right? Got it? What is conjugate? Okay. Why need to multiplying by the radical conjugate? To make the expression free from radical sign. Right? That's why we need to multiplying by radical conjugate. Okay? Alright, now let's consider this. Let's say if we have A plus B times A minus B. Okay? We have the first factor with two terms. In between is plus sign. And the second factor, we also have two terms. Same term, but we have the opposite sign in between, which is minus. Okay? Let's say if we multiply between the first factor and the second factor. Okay? We multiply A times A. So we get A squared. Okay? Then we multiply A and negative B. So we get negative AB. Right? After that, we multiply positive B and A here. So we get positive AB. And then we multiply plus B and minus B here. So we get minus B squared. Right? And then from here, we have same term. Minus AB and plus AB. So we can cancel it. Right? And then after we simplify, we get A squared minus B squared. Right? Okay, so from here, after we expand A plus B times A minus B, we get A squared minus B squared. Right? Or we can use this formula. Okay? You can memorize this formula. A plus B times A minus B equals to A squared minus B squared. Okay? Same goes to if we multiply A minus B in front and then times A plus B. Okay? We still get this answer. Okay? Got it? Alright, now let's try some examples. From this formula, the products of two conjugates is the difference of two squares. Right? This result is very helpful when simplifying radical expressions. Let's say we look at example A. Third x plus 2 times third x minus 2. We have same term, but in between we have opposite sign. Okay? If we multiply this using this formula, we will get third x bracket squared and then minus 2 squared. Okay? When we compare with this, our A equals to third x and our B equals to 2. Right? And in between, after we expand here, we get minus sign. Right? Remember, the products of two conjugates is the difference. The difference means in between is minus of two squares. Okay? We have squares here. Right? And after that, we can simplify squares and third or radical here. Okay? Then, after we simplify, we get x. And then minus 2 squared equals to 4. And from here, there is no more radical sign. Okay? That's why we multiply by the conjugate to make the expression free from radical sign. Right? Let's look at other example. Okay? From this formula, now we continue with B. 3 minus zx times 3 plus zx. We have same term, but in between we have opposite sign. One is minus and one is plus. Okay? Means the factors is conjugate for each other. Right? So from here, we can use this formula. Okay. From here, you can see that minus comes first. Okay, for the first factor. Okay, and the second factor, we have plus sign. Okay, but it's okay. We still can use this formula. Right? And then using this formula, our A equals to 3 and B equals to third x. Okay, so from this formula, we can write equals to 3 squared and then in between minus and then third B squared. Right? Remember, in between must minus. Okay, and then we have squared here. Okay, after that, we can simplify squared and third or radical. Okay, 3 squared equals to 9 and then minus x. After we simplify 2 squared and radical here. Okay, so from here, you can see that there is no more radical sign. Right? That's why we multiply with the conjugate. Okay, if the function is given in radical. Right? How about C? Let's say if we have radical 1 minus x plus 2 times radical 1 minus x minus 2. Okay, we have two terms here. Okay, the first term is radical 1 minus x. This is considered one term. Okay, not two term because 1 minus x always come together. Okay, because 1 minus x inside radical sign. Okay, this is the first term and this is the second term. Okay, we have same term but in between we have opposite sign. Okay, means we have multiplication of the conjugate. Okay, and when we multiply, we can use this formula. Okay, so from here, this is the first term and this is the second term. So we can write this. Okay, our A equals to third 1 minus x. So we can write third 1 minus x squared. Okay, and then our B equals to 2. So we can write 2 squared. In between is minus. Right? In between must minus sign. Okay. And after that, we can simplify squared and radical or third. Okay, or square root. So after we simplify, so we get 1 minus x and then 2 squared equals to 4. So we get minus 4 here. Then we simplify, so we get 1 minus 4 equals to negative 3 and then minus x. Okay. From here, you can see that there is no more radical sign. Okay, if we multiply with their conjugate. Right? Got it? Alright, now we look at D. We have 3 minus third x minus 1 times 3 plus third x minus 1. Okay? We have A, when we compare, our A equals to 3 and B equals to third x minus 1 or radical x minus 1 or square root x minus 1. Okay? This is the first term and this is the second term. And in between is opposite sign. Means we multiply by the conjugates. Right? So from this formula, after we multiply by the conjugate, we will get A squared minus B squared. Our A equals to 3. So we get 3 squared. Our B equals to radical x minus 1. So we get radical x minus 1 squared. And in between must minus sign. Right? And after that, we can simplify squared and this radical. Okay? Then we get this. Okay? 3 squared equals to 9 minus x minus 1. Okay? No more radical. Okay? Alright, now we can see that in between is minus sign. And after minus sign, we have two terms here. Okay? So, you must put bracket here to avoid error. Okay? Because from here, we need to expand. Okay? Alright, and also from here, no more radical sign. Okay, so we can expand. Okay, when we expand, we have 9 minus times x, we get minus x, minus times minus equals to positive 1. Okay, that's why we need to put bracket sign after minus sign here. Okay. Right, so from here, we can simplify. So we get 9 plus 1 equals to 10 minus 1. Okay, no more radical sign when we multiply by the conjugate. Right? Got it? Right now, we look at example 1 under limits involving radicals. Find limit x approaches 4 set x minus 2 over x minus 4. Let's say we use direct substitution for this problem. Okay, from limit x approaches 4 set x minus 2 over x minus 4, after we use direct substitution, we just plugging 4 into whatever x here. And when we use direct substitution, no more limit expression. Okay, so we have square root of 4 minus 2 over 4 minus 4. Okay, square root of 4 equals to 2. So 2 minus 2 over 4 minus 4, which is equals to 0 over 0. And remember, 0 over 0 is error or indeterminate. Okay, so we cannot use direct substitution. Okay. The correct method is as follows. Alright, let's say we have limit x approaches 4, set x minus 2 over x minus 4 here. Okay, from here, we have numerator with radical sign. Okay, so we need to multiplying by the conjugate of numerator. Okay, so from this question, we multiply by set x plus 2. Okay, conjugate means we use the opposite sign. Okay, alright, so we have same term but the opposite sign. Okay, set x plus 2 over set x plus 2. Okay, we multiplying top and bottom by the conjugate. Why we need to multiplying top and bottom by the conjugate? Okay, because since the top and bottom are the same, that means this fraction is equals to 1. Okay, and when we multiply by 1, it will not change its original value. That's why we need to multiplying the top and bottom by the conjugate. Okay, in this case, we choose the conjugate of numerator because the numerator is given in terms of radical. Okay, because we want to simplifying the radical sign here. Right? Alright, from here, we multiply fraction by fraction. So we just multiply numerator and multiply denominator and denominator. So we get this. Right? Right, from numerator here, you can see that this is the conjugate each other. Okay? So, in this case, we can simplify using a plus b times a minus b, which is equals to a squared minus b squared. Right? But in denominator, there is not conjugate each other. Right? So, in this case, we no need to expand. Okay, if we have not conjugate each other. Okay, we just expand and simplify the term that has conjugate each other using this formula. Right? Right, after that, when we use this formula for the conjugate each other here, okay, so we get this. Our A equals to set x and our B equals to 2. So using this formula, we can write set x bracket squared minus 2 squared. Okay? And for denominator, we no need to expand. We just write the same factor, right? Right, after that, we can simplify squared and set here. So we get x minus 2 squared equals to 4. And we still have the same denominator because we not expand. Alright? Right, from here, you can see that we have same term in numerator and denominator. So we can cancelling. Okay? Or we can simplify. And after we simplify, we get limit x approaches 4 and then 1 over third x plus 2. Okay? From here, we still have limit expression. Alright? After we simplify, then we can use direct substitution. And after we use direct substitution, no more limit expression. Right? So we just plugging 4 into variable x here. So we get 1 over square root of 4 plus 2. Okay? After direct substitution, no more limit expression. Right? Then we simplify, so we get 1 over square root of 4 equals to 2 plus 2 and equals to 1 over 4. Okay, this is the final answer. Right? If we use direct substitution, the answer equals to 0 over 0, which is error. But to solve this problem, when the function is given in radicals, we need to multiplying by the conjugate. But we need to multiply the top and bottom by the conjugate, because if the top and bottom are the same term, means it's equals to 1. So when we multiply by 1, it doesn't change the original value. Right? And after we simplify, we get this. Okay, after we simplify, then we use direct substitution, and then the final answer equals to 1 over 4. Alright? Got it? Coming up next, still under method 3, evaluating limits involving radicals using multiplying by the conjugate. Okay? If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.